Okay, so we're gonna use probability trees to determine probabilities when you are given. Let me go right here. Come on, selection tool. When you're given conditional probabilities, because this is when the probability trees work out very nicely. So here's our situation. Come on. Yes. You're going to see it in problems. You're going to have to decipher it from problems. And in most problems, they won't say conditional, and they often won't say given. If you look for the word if, that's usually an indicator for a conditional probability. So you're going to see that today. So let's assume there is a test. Like one of these genetic tests or whatever, for a certain kind of cancer. And we're going to say it's 98% accurate. If you actually have the cancer. Oops. And not, yeah, it's like 82, yeah. And 97%, and we always did this with CPM too, the same kind of problem. We're going to call it 97% accurate if you don't have the cancer. Okay. And let's assume that 5% of the population actually has this cancer. So just making some numbers up. So you go to the doctor. One of our teachers is going to the doctor on Wednesday to have one of these kind of screenings done. So you go to the doctor, not me, and you have the test. And the doctor calls you in a few days later and tells you you've tested positive for the cancer. Should you make out your will? Although the math has nothing to do with these should or should nots. All right. Should you go have a drink? Should you tell your spouse? Should you plan a long trip somewhere that you've always wanted to take? Okay, so we will use. Sorry, let me go back and hit this one. Undoing stroke. What did you tell me to do last time to make the box? So just pull the corner down. See, it wants me to go to the middle, which is way the heck over here. You gave me a shortcut for doing that the last time, and it worked really fast and really nicely, and I can't remember what it was. Well, no, because then it makes the writing too small. So that's why I do this. Okay, so here we go. 5% of the population has this cancer, so we are going to make a tree. So we're going to make little branches on a tree. Our tree is going to look nothing like a real tree. and not even like any real branches. So here's what I do is I make a couple of branches. I start on the left-hand side. This is how I make my trees. And 5% of the population has the cancer, so I'm going to make one of the branches of my tree be cancer, and the other branch of my tree be no cancer, and I'm just going to put a slash through my C. Okay, then I'll mark with my C. I'll put a 5% with the C, and so how much of the population doesn't have the cancer? 95. Okay, we got that one pretty good. All right, now you've taken the, anybody in the world can take this test if you have health insurance, of course. A little advertising there, and so if you have this cancer, the test is 98% accurate in diagnosing that you have this cancer. Okay, so we call that you're going to test positive for the cancer. Okay, 98% of the time. And those people with the cancer, this test is not completely foolproof. A certain percent of people with this cancer will test negative for it. And that'll be 0.02. Now, these are conditional probabilities because this 98 and this 2% only applies if you have the cancer. So these are conditional probabilities kind of hidden inside these words. Okay, so let's look at if you don't have this cancer. Let me make a couple more branches. If you don't have the cancer, should you be testing positive or negative? Oh, negative. And it's 97% accurate. So 97% of the people who don't have cancer and are tested for it will get a negative result. And 3% who don't have the cancer will get a positive result. Okay, so let's figure out some probabilities here. Let's figure out the probability that anybody that takes this test is going to have a positive result. Okay, so you're either going to have cancer and test positive. So that's the probability. I'm going to go C and positive. Or you have cancer, you don't have cancer, and you test positive. So I'm going to do no cancer and test positive. Okay, let me write this out a little bit better. The probability that you have cancer and test positive is the probability you have cancer times the probability that you have cancer, the probability that you test positive given you have cancer. Or plus, the don't have cancer and test positive is the branch down the 95 and the 0.03. Alright, so I did these numbers earlier, so hopefully they turn out right. That's 0.049 because I can never trust you guys to bring a calculator and even try to do these. 0.0285. So the probability that you test positive is 0.0775. So the probability that anybody tests positive for this cancer is 7.75%. Okay. Obviously, not everybody has cancer. So there's a higher percentage of people testing positive than actually have the cancer. All right. Now we're going to go with you or your uncle or whatever who's gotten this result.